All right, so we're going to go ahead and do Unit 4 today, specifically 4.2, and actually I needed to edit this already. We're not going to do 4.4, but we are going to review quite a bit of information on simplifying radicals and Pythagorean theorems. So we're going to take a little bit of a timeout today to do that. Okay, first and foremost, for 4.2, we have transversals and parallel lines. So you are going to start to have warm-ups in today's lesson. All of your warm-ups will be based off of previous material. I'm going to continue doing this for the rest of the semester, and you will also have review questions that pop up from old assessments. We won't necessarily be reviewing this, but this is just to get you used to recall. So you can't just learn something for 2 days and forget about it. You're expected to remember all of your math from now on in calculus. That random stuff like this will just pop up. So obviously when I do put these on the test, I am going to be picking the ones that are the most popular. All right, so let's go through some vocabulary first. A transversal is a line that intersects two lines at different points. So for example, here's your two lines, P and Q, and the transversal is line T. So basically the transversal crosses through two lines at a specific point. And that's a definition of a transversal. We have corresponding angles, same side interior, alternate interior, and alternate exterior angles. So here's how that works. Corresponding angles lie on the same side of the transversal on the sides of the intersected lines. So, for example, the way that you think of corresponding angles is where the location of the angles fall. So when I'm talking about angle 1, for example, that is a corresponding angle to angle 5. So think about it. If I look at this top part here, P, as one section and this bottom part as another, they're located in the exact same place. For example, the number 1 is in the top left-hand side. So the number 5 is also in the top left-hand side of that bottom line. So another example of a corresponding line would be if I chose angle 3. Angle 3 and is in the bottom right-hand corner. So for my Q line, the bottom right-hand corner value would be angle 7. Those are examples of corresponding angles. Same side interior. Same side interior means that they're going to be inside these two lines. So interior means in between these two lines. And they're going to be located on the same side. So here's my transversal. They're going to be located inside, in between line P and Q, and they're going to be on the same side of the line. So that's why 3 and 6 work. Another one for same side interior is angle 4 and angle 5. They are also still in between lines P and Q, and they're on the same side of that transversal line. Alternate interior. Okay, for alternate interior, I like to picture that as hopping over the line. Anytime you see the word alternate, that means that you're going to cross over the transversal. So an example of an alternate interior is right here, angle 3 and angle 5. I skipped over the line. So another example of an alternate interior is going to be angle 4. Interior again is between P and Q, and alternate just means cross over the line. So angle 4 and angle 6 are also alternate interior angles. So alternate, you might want to make a little note, means hop over the line. The word interior, because these are used in multiple definitions, means in between the lines. That's just for interior and alternate. So because I see the word alternate here, that means I'm going to hop over the line, and then exterior means it's going to be on the outside of the line. So basically don't pick any angles in between P and Q. So I'm sorry, alternate means I'm going to hop over the line. So if I'm looking at angle 2, I'm going to hop over the line to the other side of the transversal and go all the way down to the next exterior angle. So angle 2 and angle 8 are also examples of alternate exterior angles, in addition to angle 1 and angle 7. So it takes a while to be able to get all of these down. And obviously with the way that I'm drawing it, it's kind of difficult to see these. So let's go ahead and look at these a little bit further. Now, the difference here is that you will notice that this particular graph, the transversal is cut by 2 parallel lines. And the reason that I know these are parallel is you see this little arrow that they wrote? Anytime you see those arrows, that means that the 2 lines that have that signal on them are going to be parallel. Okay? So this is how you're going to figure out certain measurements of angles, because when you're utilizing these postulates that are very similar to what I just went over with you, these will tell you if they are congruent or if they're supplementary. So let's look at same side interior. Same side. Here's my 2 parallel lines. I'm going to try redrawing it because that didn't work very good last time. Here's my 1, 2, 3, 4, 5, 6, 7, 8. Same side interior postulate. So let's say, for example, my same side is going to be 3, for example. And interior means it has to be between these 2 lines. So I'm going to pick 3. And same side interior angle. Same side means I'm going to stay on the same side of the line. So do not cross over. Cross over means alternate, right? Same side interior. The only other interior angle that's on the same side is angle 6. And the comparison about alternate interior angles is that they are supplementary angles. So supplementary is an old vocab word from a couple of days ago. Supplementary means they're a linear pair, which means that they add up to 180. So when you have same side interior angles, you're going to set them equal to each other. I also could have utilized angle 4 and angle 5. Those are still interior angles because they're in between lines P and Q. And the same side part means that they're on the same side of the line. Oops. All right. For my next one, I have alternate exterior. Let me go ahead and draw this again. P, Q, 1, 2, 3, 4, 5, 6, 7, 8. All right, so for this one, we have 2 parallel lines are cut by a transversal. So alternate interior, let's figure out what that is. Again, the word interior means that it's going to be in between lines P and Q. So I'm looking at this portion. Those are the only angles in between lines P and Q. And alternate means that I'm going to hop over the line. So alternate interior angles would be angle 3 and angle 5. I'm hopping over the line. So the comparison between angle 3 and angle 4 is that these ones, if 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles have the same measure. So basically this is saying that angle 3 is going to be congruent or equal to angle 5. Another set of alternate interior angles would also be angle 4, which would be equal to, hop over the line, angle 6. Okay, next one. 1, 2, 3, 4, 5, 6, 7, 8. Corresponding angle theorem. Corresponding angle theorem is all about the location of your item. So for example, there's lots of corresponding angles here. In fact, there's 4 of them. Let's just say I randomly pick number 1. I'm going to look at line P, and I'm looking at number 1, and number 1 happens to be in the top left-hand corner. Top left-hand corner. Now I'm going to go to line Q, and line Q, the one in the top left-hand corner, happens to be number 5. So angle 1 and angle 5 are corresponding angles because they're both in the top left-hand corner when I'm referring to my line P and my line Q. Okay, so the theorem says that the corresponding angles are always equal. Let me pick another set here. So let's go ahead and let's look at 3. Angle 3 is in the bottom right-hand corner if I'm only looking at the angles formed with line P. So now when I compare that to line Q, angle 3 again was in the bottom right-hand corner. For line Q, which one is in the bottom right-hand corner? Well, the bottom right-hand corner is going to be angle 7. And I could continue to go here. Angle 2 would be a corresponding angle to angle 6. Angle 4 would be a corresponding angle to angle 8. Okay, so corresponding angles means that they're in the exact same location. So let's go ahead and do an example, and these can look a variety of ways. Find the angle measure and explain why. I don't know if these are parallel. It doesn't look like they are. Let's see if I can figure out what they equal without knowing if they're parallel. All right, so the measurement of angle 4 is 64 degrees. I prefer to just write directly on the item. And my question is asking me to find angle 8. Well, I know that this is one full line in because it's labeled. So if I'm trying to find angle 8 here, these two are considered to be right next to each other, which basically there's not one for that. Those are going to be a linear pair because they line up with M, right? So angle 4 plus angle 8 is going to equal 180 degrees because they're a linear pair. I happen to know that angle 4 is equal to 64, and now I can find angle 8 by subtracting 64 on both sides. So when I subtract 64 on both sides, I'm going to get 106, 116. Okay. All right, let's go ahead and try the next one for part D. Measurement of angle 10 is 45 degrees. By the way, you're never going to go off of how these look, okay? They may tell you that it's like, I don't know, 80 degrees. It might look like 80 degrees, but it's 45. Always go off of the numeric values that they give you, okay? For this particular problem, they want you to find angle 15 over here, okay? So the correspondence between these two is that angle, yeah, these would have to be parallel then for us to solve this. So let's say there was some additional information here that said line M is parallel to line N. Okay, they should have the little mark on them. So in order to find these two, this is an alternate interior angle because it's in between lines M and N. So the relationship between angle 10 and 15, these are alternate interior angles. Alternate means we're hopping over the line, and interior means that they're in between. So if I go back and I look at it, it looks like we're here at the second theorem that tells us that these two lines are actually going to be congruent. So if angle 45 or angle 10 is going to be congruent to angle 15 because they're alternate interior angles. Therefore, if angle 10 is 45 degrees, then the measurement of angle 15 is also going to be 45 degrees. Okay, next one. We're going to go ahead and do angle 3, which is over here. Angle 3 is going to be 136 degrees, and the question is wanting me to find angle 2 here. Now, this is on the same side of the line, and it's interior because it's inside lines M and N. So it's an interior, same side postulate. Looks like we have the first one up here. And this rule says that they are supplementary, meaning that they add up to 180 degrees. So angle 2 plus angle 3 is going to equal 180 degrees. And these are same side interior. I know that angle 3 is 136 degrees, so I'm going to go ahead and plug that in. I'm going to subtract 136 from both sides, and I'm going to get 144 degrees. And that would be my solution. So if you have the theorems in front of you, it's not too difficult, but the hardest part is identifying what the angles are to each other, identifying that relationship. So understanding that alternate means you're going to cross the line. Interior means inside. Exterior means outside, you know? You really got to know that stuff. So suppose angle M. Let's look at angle M now. This is 124. I'm focusing on this orange color. And my goal is to find 16. All right, so this one, am I hopping over the line? So I'm comparing this line here, line Y, and I'm using line M and line N as my parallel lines. So first of all, are these interior in orange or are they exterior? Interior means they have to be in between the two lines. I know that we have 4 lines here, so that's a little difficult. So focus in on the orange here. I'm not even looking at the top green line. I'm only looking at the orange. So obviously I have 124 and angle 16 over here that I need to find. Those are not in between my 2 parallel lines. So this is going to be an exterior question. And now I need to know, are these angles on the same side of my transversal line Y here, or am I crossing over? So 124 is here. In order to get to 16, I do have to cross over line Y. So that means they are what? Whenever you cross over, that means that it's going to be alternate. So alternate exterior angles. Alternate exterior angles. What is the relationship for alternate exterior angles? This one's a little bit harder, but basically they are going to be equal. And the reason being is because I could use vertical angles here. I could use corresponding angles. I know that if this is 124, then angle 14 is 124. Angle 11 is 124, and by vertical angles, I could get to 16 again. So measurement of angle 9 is 124, right? By corresponding sides, I know that angle 9 equals angle 11. I'm just writing out my thinking. Okay. And then I also know, so then this means that if angle 9 is 124, then angle 11 is 124, and I could write it here. My goal is to get to 16. So I know that if angle 11 is equal to angle 16 because that's a vertical angle. I see an X there. So therefore, if angle 11 is 124, then angle 16, if I plug in, is also 124 degrees. So here's the deal. When it comes to these types of problems, you have 2 ways to answer it. One is that you either have the angles that are going to be congruent to each other, so you're going to set them equal, or they're going to create a linear pair. So when you see this in a future test, if you're not sure what to do, at least you have a 50-50 chance of getting it right. Either set the two items equal to each other or add them up and set them equal to 180. Those are your only choices when working with this. I know my notes or my video is taking a little bit longer this time, and that's because these aren't the easiest. It takes some practice. All right, let's go ahead and try this one. Find the value of x and find the angle measure. Find the angle measure of STU. So we have here kind of like an example of a road. Just make sure you understand we got a couple of degrees here, and we're going to pretend that these are straight lines because that's how our roads are made. So really I'm wanting to find x. So I want to look here. This is, if I feel like you need to redraw it, then do that. But this is what we have. I have that and I have that. So these are alternate. I'm hopping over the line, right? Alternate, and they're exterior because they're outside of lines A and B. So we just did this on the last question right now. And you can just remember it if you'd like, but alternate exterior theorem, they are going to be equal to each other. Or if you don't like that, you could just go through your reasoning. Bottom right-hand corner, corresponding side is also bottom right-hand corner. And by vertical angles, these two angles are congruent. Okay, so since they are, I know that they're equal, then obviously the way that I can solve for x is by setting them equal to each other. So remember, I could do one more example, and let's say my other angle was here, and I had 2x minus 22. Well, this would be an example of a linear pair, so then I would add these two items together and set them equal to 180. So you're still, when you're solving, you're doing one of two things. You're equaling them to each other, or you're adding them up and setting them equal to 180. I'm going to move my x over by subtracting x on both sides. I'm going to add 22 to both sides, and I'm going to get x equals 62. So I found x, which was one of the questions. Now I'm also asked to find the angle measure for STU. So STU is right here. So be careful. This is going to be a linear pair. So to find the degree measure, I can start here with 2x minus 22. I know that x is 62. So 62 times 2 is going to be 124. Minus 22 is going to be 102. So if this angle is 102 degrees, then I know that 102 degrees plus angle STU is equal to 180 degrees because they're a linear pair off of line B. So all I need to do is subtract 102 on both sides, and I get angle STU equals 78 degrees. All right, now it's your turn. Go ahead and try this question. And remember, you guys are so lucky. You have so many different resources you could use to help you. If you're struggling with this, you can always go on Google or YouTube and look up additional examples as well. I expect to see quite a few questions on this from homework, so please try your best and make sure you continue to use the collaborate section, all right?